Hello, everyone. Ladies and gentlemen, let me introduce myself to you. My name is Summer Shafi, and I will be your event coordinator for today's webinar session. I hope you are all doing fine. Here, the overview about skills here. After the spread of COVID-19, many businesses collapsed. A lot of companies weren't able to survive. They couldn't adapt the changes that happened in the world. The need for new technologies became a must. Skillshare filled this gap in the market using the latest methodology in organization analysis. At Skillshare, we are having three core values, which are authenticity, professionalism, and customer commitment. Concerning our consultation and training courses, we are providing consultation and training courses to many different companies. And we are here located in Egypt as a headquarter, but we are working in the whole Middle East region. Our vision. Concerning our vision, we are here to help you to grow your business. And we really care about your time, as your time is priceless. Our mission. Our mission is to provide you with the experience you need or the experience you're looking for. We use data analysis to provide tailored solutions to advance your business. We are here to build the capacities of your team members, and we are here to help you to gain more clients. Our big idea, as we said before, we are here to help you to grow your business, and we are here to help you to adapt the changes that happened in the market. Concerning our team, we work with experts inside and outside Egypt. As I said before, we work in the whole Middle East region, and the formula of our team members are mobility, diversity, and competence. The services we offer two types of services, which are consultation services, training services. Consultation services, organization analysis and evaluation, business planning, change management, corporate culture. Concerning training services, we provide you with health and safety training courses, oil and gas training courses, management and leadership skills. Concerning the instructor profile, his name is Mr. Ahmed Al-Attar. He earned his degree at Faculty of Engineering, Cairo University, 2010. He got a master's degree in Petroleum Engineering, Faculty of Engineering, Cairo University, 2018. About his experience, he is a man with 11 years experience of progressive experience in different operation designs, execution, and evaluation. About how to contact us, you can contact us using our website, which is www.skillshare.com, or you can call us using one of the phone numbers here. We are having 0114999856 or 0115-330-1501. And don't forget our code is +2. And you can email us by sending an email on info@skillshare.com. And Skillshare is existed on 3 different social media platforms, which are Facebook, LinkedIn, and Instagram. Thank you for listening to this overview about Skillshare. Don't leave, just stay with us. The mic now goes to Mr. Ahmed Al-Attar. And don't forget, at the end of this webinar, I will have to tell you more about the details about the certificate. So stay with us. Stay with Skillshare, as Skillshare provides you with a real practical experience. Now the mic goes to Mr. Ahmed Al-Attar.
Thank you so much, Summer, for this introduction. I'd like to welcome all the participants to this free webinar about such an interesting topic, which is stuck pipe prevention during drilling operations. I hope that after this session, you gain valuable insights into the topic. We tried to make it at an intermediate level to be suitable for most of the attendees. So this training will just be like a basis for you to understand more about this topic, and for sure you can grow your experience by reading more references, and also you can contact us for questions and inquiries after the session through the email of SkillServe organization. Also in the beginning, I'd like to thank the management of SkillServe Training Company to give me such a great chance to get in touch with this number of participants who are interested in knowledge sharing and knowledge gaining. And I hope you benefit from it. So in the beginning, I'd like just to make sure that my screen is shared. So Summer, you can see it clearly?
Yeah, I can hear you. Go ahead.
Very good. Okay. So I'll start my presentation with the outlines. So we will talk about four main dimensions. The first one, we will introduce you to the problem of stuck pipe. Okay. And in the second section of this presentation, we will talk more about what kind of parameters should the drilling engineer, the mud logger, and the different team members who are participating in the drilling activity should be focusing on to assist them in the early detection of a stuck pipe event, and what can we do to ensure that our hole is properly cleaned during the drilling operation, because those two things are like crucial for the whole team members working in the drilling activity to detect a stuck pipe event before it's occurring. So it's all about prevention here. Then we'll talk about the stuck pipe types and what kind of remedial techniques should we deploy to free our pipe. And we'll end our presentation with recommended practices and sound engineering techniques that should be adopted during different parts of the drilling activity to ensure that we are doing it right. We are avoiding any unnecessary cost of remedial work, of fishing, of site cracking. So those are going to be the main outlines of my presentation. So I'll start now with the definition of a stuck pipe. So according to the American Petroleum Institute, a stuck pipe event is defined when the normal drilling operations is interrupted for 1 hour or more because we are unable to retrieve or move the drill string up or down, right? Okay, so pipe sticking can occur during different phases of the drilling operation. So whether it's drilling, whether it's completing the well, whether while making a connection, logging, or running casing, okay? So moving forward, in this pie chart, you can see a graphical representation or the percentage of occurrence of a stuck pipe event during different drilling activities. So as you can see here, 30% of the stuck pipe event occur during tripping, which is pulling out of hole with the drill pipe, either to change the BHA or to install a new PHA, a logging PHA, for example, or while running again to continue drilling. So that constitutes around 30% of the whole drilling activity. And then we have 40% during drilling itself, right? And 13% during logging operation, and 17% during other miscellaneous operation. And we talk about miscellaneous operation, we're talking about spotting a cement block, we're talking about milling cement, activities like that, okay? Okay, so what is a cost of a stuck pipe incident and why we should exert all our efforts to prevent it from occurring? So in the very beginning, once you have a stuck pipe event, you have operational non-productive time, right? You're not achieving rate of penetration, you're not drilling, you're not progressing with your drilling activity, and the whole operation, the whole services company in your location are on hold. You're all waiting to correct the situation. So this is the first one. And then it may lead to costly fishing operation, because at some point you may not be able to retrieve the pipes. In such a case, you need to back off, or you need to cut the drill string from inside, and you need to call a specialized fishing company to fish the tool string. And like the worst case scenario, if you cannot correct the situation, you may need to sidetrack. So that means you will adjust the original course you choose for drilling, you will set a whip stock, and then you will a different hole. which is very costly and very time consuming, right? That's why this course will give you a manuscript, a complete guideline on how to detect this issue, how to prevent it from happening. And it's very evident that it's a very important topic, and all the people, all the stakeholders who working in the drilling industry should be well aware of it, because it will be shown to you later in this presentation that it's all about teamwork, it's all about synergy, it's all about proper communication between all the different parties. As mentioned, due diligence and recommended drilling practices should be followed at all times to avoid any circumstances leading to an event. And we have to follow the sound drilling engineering techniques, and team synergy could save us a cost of a sidetrack. Okay. Here we will talk about the monitoring part, which is very important. Like, what kind of parameters should we monitor to ensure that our drilling is going as per plan, to make sure that we are from a stuck pipe scenario. So the drilling, we monitor all the drilling parameters. We have to have the full picture. It's not only about circulating pressure. It's not only about surface torque or differential pressure at the motor. You have to have the full picture in front of you to be able to understand what's happening. So there is a very important adage in the drilling industry. It's telling you that the well is talking to you all the time. So how do you listen to it? How to interpret the signals that are coming from the well? And to start explaining this more, I need to touch base quickly with the mud system in the rig. I'm sure if you are working in this domain, you're well aware of it, but I'll just give a quick glimpse for people who are not, like for fresh graduates or people who are not specialized in drilling engineering. So as you know, during drilling, there is a complete system called the mud system. In this system, we are circulating drilling mud into the hole and out of the hole back to the shale shaker, where we condition it and pump it again. The primary reason why we do that is to make sure that we are having a hydrostatic pressure in the well bore that's with the reservoir pressure. So the primary purpose of the drilling mud is well control. We are controlling our well. We are ensuring that we're hydrostatic pressure that's equivalent or slightly greater than the formation pressure, and this happens in overbalanced drilling, which is most of the drilling operation are done in an overbalanced mode, unlike the underbalanced, which is not the topic now. Okay, so as you can see here, we have the mud pits. Those are the tanks that store our mud. This mud is mixed by a specialized mud company. It has a certain rheology that gives the mud its desirable properties for better carrying capacity of the fluids, for proper density to control the formation pressure. So as you can see, here is the path. The mud goes to the mud pump. Those are triplex pump. And then we have the discharge line to the stand pipe, and then the rotary hose. And then the mud will travel all the way down through the drill pipes, drill collars, and then to the pit nozzles, and it will be circulated into the annulus, carrying all the cuttings all the way up, and then it will go back to the mud pits. In the mud pits, we have the shale shakers. This is the first thing we have in the mud pit for conditioning the solids, right? It will separate the cuttings from the mud, and then the mud properties are kind of conditioned by the mud engineer. He will add more additives to get it back to its original rheology, right? Okay, so what are the parameters we are monitoring here? The circulating pressure. The circulating pressure, this is a friction that the triplex pumps of the mud will see or will need to overcome to get the mud from the discharge line up to the mud return line. So it's a very important parameter that we should keep an eye on during the operation, because it will tell you a lot about how your operation is going, as I'll explain in the next slide. The second one is the surface torque. In very simple terms, what is torque? As you are drilling, you are having your bed is rotating and is crushing the rock, right? For you to get it to cuttings and then circulate it out and get to the next strata of formation. So there is a reactive force exerted by this formation into your drill string. So this reactive force is monitored through a torque value on surface. That's why it's also very important, because this will give you an idea about what kind of formation you are drilling. It will give you an idea about the status of your well. That's why it needs to be closely monitored as well. The overpull. So while tripping out of the well, there is a simulated pickup force that we should see at the Martin-Baker. If the value of the pulling force is greater than the normal pickup weight, so you are having an overpull. So you need to understand, why do we have this overpull? Is not clean enough? Is it because I'm having excessive drag in this section? Is it because I'm having a tight spot? That's why the overpull and the Martin-Baker needs to be closely monitored. And here we have the differential pressure of the motor. This is, as you know, we are using positive displacement motors during the drilling operation. And we have a differential pressure across the rotor and the stator. And this one indicates the reactive torque you are facing. So this one also needs to be closely monitored by the directional drilling team. And then the rate of penetration, like how fast you are drilling. This is a very important parameter as well. And the last one is the pump strokes, the strokes per minute that our pump is doing to pump or to push this mud from surface to the downhole end and back to surface. So we'll take one by one and we'll explain quickly what should you understand if this parameter is increasing, if it's decreasing, or if it's fluctuating during the operation. So for the circulating pressure, what if it's increasing with me? What does it mean? So it means one of those options, like you're having an increased flow rate, your mud rate has, right? Or you're having an annular restriction, you're having inadequate hole cleaning, you're having a plugged bed, or heavier mud is being pumped. So this is a very important thing for you to monitor, right? Because you have to stop and you have to see what changed in your drilling parameters that caused this increase. If this one is decreasing, it's a little bit alarming because you may have a kick or an influx. If you are having gas in the wellbore, that means circulating pressure will drop a little bit, because as you guys are aware, the gas is lighter than the mud. Or you're having a washout in the hole, you are having lighter mud weight, or you're having a pump malfunction, right? Having the circulating pressure fluctuating, like going up and down in an erratic manner, so that means you're having a hole cleaning issue. Okay. So moving forward, the surface torque. So what does it mean if I'm having my torque increasing above the normal value? It means also that I'm having inadequate hole cleaning, or I'm having a hole angle change. So the inclination is changing at this point, or I'm having a formation change, or increased weight on bit, or a washout. That's why when such a thing happens, you need to gather with the team and see exactly what happened. Is it, are we building up an ankle? Or do we have an inadequate hole cleaning? Do we need to stop and do one bottoms up? Because catching this early on will allow you to prevent a stuck pipe from occurring. So
بس بدون زحمة تسمعني؟
Yeah, Mr. Attar, can you just slow down, because many people are saying to slow down. They can't take notes.
Okay,
yes,
no worries.
Thank you.
Okay, so what if the surface torque is decreasing with me during the operation? So that means, okay, we are having improved hole cleaning. We're not having lots of cuttings in the wellbore, right? Or speed has changed, right? Or we have decreased weight on bed, or the bed is worn out, or the mud engineer has added some lubricants to the system. So reduced the friction pressure and contributed to a reduced surface torque. And then what if it's fluctuating? So maybe we're having a drilling break. We're moving from one formation type to the next, or we're having a junk in the hole. Because if, for example, the drilling crew, the restabouts or the drilling drillers, like dropped something accidentally in the wellbore, like a pipe wrench or something like that, that will also affect your torque reading. You'll have it fluctuating. And then maybe you're having in the hole. So as you can see, each parameter can tell you a lot about what's happening in your drilling operation. Okay. Before starting the drilling operation, the drilling engineer in the town will give you a design of the normal running parameters. And by comparing between the normal and what's happening during drilling, you can understand a lot about your operation. Right? Okay, so moving forward, the third one is the overpull. So as you are aware, stripping out of hole, we are having the Martin-Baker at surface. And this is monitored by the driller, right? Onto the Martin-Baker, you would see the pickup weight, okay? So if this pickup weight is going to the normal simulated value, so you're on the safe side. But in some cases, you're having an extra pull, right? Which is unexpected. You don't know where is it coming from. So in such a case, you need to start thinking, is it because of inadequate hole cleaning? Is it because I'm having excessive drag because the inclination of the trajectory of the well has changed? Or is it because the formation has changed, that's why I'm having excessive friction? Is it because having a tight spot, or is it a formation issue, right? And if this one is decreasing, the overpull, okay, so that means I'm having the hole is properly cleaned. We have improved hole cleaning, or the formation has changed as well, or we're having better mud rheology, or the whole angle is straightening out, or the mud engineer has added some lubricity to the mud being used during drilling. Okay, so I just go back quickly because maybe you are under the ambition that I speed it up a little bit to sum up. So as mentioned here, guys, we're having, those are the critical parameters that all the people working in the project of drilling a well should be keeping an eye on. Circ pressure, surface torque, overpull, the differential pressure of the motor, your ROP and your pump stroke. And with each parameters, as we can see, if it's increasing or decreasing or fluctuating, it will propose that you are having a certain scenario. Like if the circ pressure is increasing, maybe you are having an increase in flow rate. That's why you have to stop and assess and plan. A team plan, you, the mud logger, the directional driller, the company man, everyone involved in the operation. And we talked about the surface torque, and then we talked about the overpull. Then we're moving through the differential pressure at the motor. So as you are aware, during drilling with the PDM motors, you are setting a weight on bed, right? This weight on bed, it will achieve to me a certain value of differential pressure at the motor, which is proportional to the torque we are getting. Necessary for us to overcome the resistive properties of the rock, to crush it out and make it into cuttings and clean it out of the well. So this differential pressure should be within a certain range, which is listed or designed in the pre-job design, right? So what if I'm having an increase in pressure? So this one will indicate that we are having a higher rate of mud being pumped, right? Or we are having excessive weight on bed, or we have it chunking in the motor. As you are aware, this motor is composed of a rotor section and a stator section. And this stator section is an elastomer spiral, right? So once we have the motor stalling too many times, in some cases, the rubber element which is lining the stator section will be chunked and it will be pumped along with the mud. And one of the things that you can use to be sure if chunking phenomenon is happening during your drilling operation is checking the shale shakers. While checking the shale shakers, you will get to see some rubber material coming out with the cuttings, right? Okay. And the last thing that may lead to a differential increase is the hole cleaning, right? If your hole is not properly cleaning, if you're not doing trips as necessary, that will also contribute to an increase in your differential pressure, right? Okay, so what if it's decreasing? So the decreasing will lead you to think on different scenarios. The first one is a reduced flow rate. Maybe the pump rate has been reduced, so you need to stop and check. Did this happen? Or push out in your pipe. So in case you are having like a leak somewhere in the drill string, it will lead you to a drop in your circulating pressure and also a drop in the differential pressure of the motor. So you need to stop and assess as well. And the last one, maybe the weight on the driller has reduced the weight on bed. That's why you're having less differential pressure. Because of the weight of bed got reduced, you are not crushing the rock. You're not having the same resistance from the formation as before. That's why the motor does not need to exert the same differential pressure it was exerting before to crush the rock at a higher weight on bed. Okay. Moving to the other drilling parameters that's also very important for you to monitor is the rate of penetration, like how fast you are drilling. Because if this is increasing, that means the formation is changing. Maybe you are getting into a softer formation with less reservoir pressure, or you are drilling close to balance. Because as you know, when you are greatly overbalanced from the reservoir pressure, sometimes that leads to a phenomenon called the chip hold down effect. So the cuttings are not transported to surface. They are staying between the bed and they are not traveling faster. That's why your ROP will close a little bit. So when you're close to a balanced condition, your ROP will increase a little bit, right? Okay, so what if the rate of penetration is decreasing? So that will be an indication of a worn bed. okay, or a non-optimum parameters being maintained during the drilling operation. So you need to stop and reassess. Or maybe you have a washout in this section of the formation, or you are using poor mud properties. So as you can see, it's usually not straightforward to know why one of the parameters is being changed. You need to complete a full assessment, and usually it's not related to one company. It's related to different service companies. So in some cases, you need to gather with the mud engineers, the mud loggers, the directional drillers, to come to know why this parameter has changed. It's very important, like to understand what's happening, because if you left things like that, you may get yourself into a stuck pipe scenario. The last thing we need to explain in this slide is the fluctuating ROP. So having a fluctuating ROP, what's happening? So we are having a layered formation. That's why you need to check with your geologist. Are we having a layered formation with different strengths? Okay, or my bed is wearing out, so I need to check the hours I've been using to drill with this bed. So maybe I need to take a decision to pull out a hole with the drill string, do a dull evaluation of my bed and replace it, right? And the last one is application of weight on bed. And in such a case, we need to have a look at as you know, those parameters are being logged in the driller's doghouse. So we need to look and make sure that we are applying consistent weight on bed during this operation or not, right? Okay. And here we have our last critical parameter that we need to have a look at, which is the pump strokes. Pump strokes can be explained as the opposite of your circulating pressure. Like the pump stroke is the stroke per minute, the number of strokes your plungers are doing per minute to push this mud inside the wellbore. So if it's increasing, you will find all the reasons as if your circulating pressure is decreasing. You're having lighter mud, you're having a kick or an influx, you're having some air in the pump has lost its prime and it needs to be inspected. You are having a washout, or you are having a pump malfunction, right? So if it's decreasing, you will find the same scenarios as if your circulating pressure is increasing. So you're having an annular restriction, you're having an internal restriction within your drill string, you are having inadequate hole cleaning, you are having a plugged bed, and you are having heavier mud. Okay? So now I'll talk about some advanced measurements that some companies decide to have during their drilling operation, because it will give them a real-time downhole measurement of the pressure, which helps them for the early detection of a stuck pipe scenario. It's called APWD. So an APWD is an acronym that stands for annular pressure while drilling. So instead of relying on surface parameters, the parameters that we have just mentioned, you rely on downhole measurements to know your equivalent circulation density, to manage your hole cleaning, to detect early water flow. So this is a downhole gauge, which is inserted along with the MWD tools, and it will give you a figure of the pressure downhole near the tool string. So with this, you can better control your drilling efficiency. You can also accurately do your leak of test and formation integrity test, okay? It's also very useful in underbalanced drilling operations, because you have an idea about the pressure exerted by the mud at the downhole end, and it will optimize your trimming process because you'll avoid any surging or swabbing effects. Okay. Okay, so after talking about the critical parameters during the drilling operation, here I'll talk about the hole conditioning and monitoring. So how do we monitor our hole? How we make sure that it's properly cleaned at because that will give us confidence to go on and continue with our drilling operation. So the most common flow that that happens in most of the operations is that we assume that our parameters should take a linear shape. Okay, that could be assumed in a well scenario. Although also in a vertical well scenario, it has been proven that most of the parameters are not taking a linear shape, because you are having lots of things that coming into play with you, like the torque, the drag, the wellbore condition, and all that. That's why you cannot know what's abnormal if you don't understand what's normal. So what's normal should not be assumed. It should be properly simulated before starting the operation. You should also rely on information from your offset wells because understanding your baseline scenario will give you an idea on when you are deviating from it. You should take an action to get back your operations to the normal track. Okay. So what kind of tools are we using to monitor our hole cleaning? So the first tool that we are using is a PWT, the pressure wide drill, right? This one is very useful in vertical well. However, in deviated or high angle wells, it's not that useful, because if you're having sand bedding, right, it will not be clearly seen by the pressure wide drilling tool. That's why you need to get to some advanced techniques to understand more about your hole condition in deviated and high angle wells, like cuttings, weighing, like MWD, surface torque and weight on bed. And the last one and the most advanced one is drag and torque trend monitoring. We'll talk about each one of them in a little bit of detail in the upcoming slides. So BWT, as I explained earlier, is a tool that's put in the tool string, and it gives you a real-time measurement of the downhole pressure near the bed, right? And with this, you can avoid exceeding the frac pressure of the formation. You ensure that your chip hold down effect is kept to the design value, so your rate of penetration is optimized, and it will help you avoid losing your mud into the formation if you are like greatly overbalanced over the formation pressure. But why is it limited in high angle well bores? Because as explained earlier, the cuttings bed will not be visible to this tool also, because most of the cutting seen on the PWD will come from the near vertical hole section. However, if you are in the horizontal section, so this tool will not be able to see this bedding phenomenon. And you need to get to some advanced techniques. Okay, so what is weighing of the mud? Weighing of the mud, as you know, the mud logger is entrusted with this task. So they will go to the shell shaker, and frequently they will weigh the mud. They will make sure that if you are getting sufficient returns, if you are having proper cleaning of the well bore, or the cuttings are decreasing, we are not getting cuttings proportional to the rate of penetration we are drilling with. So it's very clear that this one is very important, because if you are not getting a cutting weight proportional to your rate of penetration of drilling, that means this cutting is inside the well bore and it's affecting your whole cleaning, and you need to take an immediate action about that. So whether it to stop and do a wiper trap, whether it to improve the rheology of the mud to enhance its carrying capacity, and lots of other solutions. But as mentioned, it's not only a one thing, it's a full picture that you need to gain to get to know what's happening during your drilling operation. Also, the cutting character will give you an idea about what's happening. So for example, as you can see in this figure, this is splinted cutting shape. It gives you an idea that you are having excessive differential pressure. So this shale is getting scrapped out of the walls of the well bore. So the weight of the mud, the character of the mud, it gives you an idea about what's going on. It gives you an idea about the condition of your hole cleaning efficiency. The last advanced technique we mentioned about is the torque and drag. And quickly here in very definite points, I'll explain to you why it's very important. Torque and drag will give you an idea about the drillability of your well, right? And it will define to you what kind of rig equipment you need to efficiently drill this well bore. Moreover, it will help you optimize the trajectory and the BHA and the tool string design, right? And also, it will help the mud engineer to establish the mud program needed to drill a certain section. It will identify problem areas like hole cleaning, like tight holes, and it will assist you in evaluating the effectiveness of your hole cleaning and taking proper action to ensure it's done properly. Because as I think it's clear for you now that hole cleaning is the leading reason for having a stuck pipe scenario. And then with the torque and drag trends, you can also decide if a reaming or a back reaming action or a short trap is needed to make sure that this spot is properly drilled, right? And it will give you an idea early on if you are getting into a stuck pipe event. Okay, so quickly here, we need to talk about this parameter in specific, because it's one of the most important parameters for the stuck pipe prevention event. So what does it mean if I'm having my torque and drag increasing? What kind of serious problem do I get from, or do I understand from the torque and drag measurements? The first one is the cuttings buildup. if your torque is increasing, if your drag is increasing. So what does it mean drag? Like friction between the pipe and the walls of the hole. So if I'm having drag, if I'm having overpull, that means I'm having cuttings buildup, or maybe a wellbore stability issue, shale sloughing or something. Maybe I'm having I need to do a back creaming run, right? Or this section of the wellbore is having higher torque than planned. Okay, or I'm having a rig equipment problem, or I need to change my bottom hole assembly, or I'm having a washout in my wellbore. So as you can see, you can get a lot of information from the torque and drag trends. Okay, so what can we do to ensure that the torque is reduced during the drilling operation? So the first one is a weld trajectory. You need to plan your weld trajectory in a way that it excessive dogleg severities, right? It's smooth for the drilling operation. Also, the casing, the cased hole design and deciding your casing points, the lubricity of the mud, the lubricating beads, and also the use of loss of circulation material and torque reducers. Okay. In the well path consideration, we need to plan the trajectory of the well, your bottom hole assembly, and the optimum profile that you should be taking to drill or to get to your sweet spot reservoir. Okay, on the drag side, how to optimize the drag. So drag is optimized in a similar fashion to your torque by improving your well profile, by having a plan for mud lubricity, by also using drill pipe protector, by adjusting the buckling effects and the weight into your tool string, and also by ensuring the hole is clean at all times, by rotation, and by using the rotary steerable systems. I'll end this section with some general guidelines for torque and drag optimization. So, and those are sound engineering practices that should be deployed in any drilling activity. You should keep your BHA as light and as simple as possible. You should place the heaviest drill string components in the vertical hole section. And you should keep your tortuosity and dog legs to a minimum. And this one, it's done at the design phase of your well, right? And as much as you can, it's advisable to use the rotary steerable systems. They are more expensive than the conventional system, but they are proven to yield better torque and drag values. Also, you need to ensure that the proper hole cleaning is maintained at all times. You don't have any cuttings in casing, because this will increase your torque and drag significantly, and the settling of those cuttings around the wellbore may contribute to having a mechanical stuck event. That's why it should be monitored and avoided at all costs. The last one, you should define before starting your operation, where are my thief zones, and you should have a plan to address them, like loss of circulation and other pelts that should be used to control this, because that will lead to a differential stuck scenario. And also you should run your torque and drag simulations early on to get to know your baseline, because as mentioned earlier, without knowing your baseline, you will not know when you are having an abnormal scenario, and you'll not be able to take proper decisions for adjusting to the normal course of drilling. Okay, so now I'll come to like the last section of my presentation, which is talking about the different mechanisms for getting your pipe stuck. Like we have three main mechanisms. Some literature will define them into two. It's different, the classification is different, but I found that this is the best and most comprehensive one. We have differential sticking, we have mechanical sticking, and we have related to wellbore geometry. We will touch base with each one of them in a quick way. So first of all, how can we determine the stuck pipe mechanism? So there are some steps that the driller and the drilling engineer should walk through to define under which category of pipe sticking they are falling in. And this one, they start moving their pipe up and down, they start rotation, they start pumping, and some sheets like this one, they need to fill in. And like this one, for example, you will circle, like let's say you're moving up. Okay, so here you will circle this one, right? And with the summation for the greatest total, you know under which stuck mechanism you are falling. So is it a differential sticking? Is it a back off? Is it a geometry? Based on you answering those questions. So once you answer those questions, you will get the totals. This is a rule of thumb, and some other companies, they have their own software that helps them to define the stuck pipe mechanism they are having. And once you do that, Okay, you have a better idea about the stuck mechanism, and you can start applying the playbook for this type of stuck mechanism to free your pipe. Okay, so for differential sticking, what can we do to free the pipe? What is differential sticking? This will be explained here in this section. Okay, so differential sticking is what are the mechanics of differential sticking? It's all about differential pressure, contact area, and permeability, right? So differential sticking, it happens when you're having excessive differential pressure between the pressure in the well bore and the formation pressure. So in this manner, your drill pipe like got stuck in the walls of the well bore, right? So how to avoid it, and what are the operational practices that used to detect it? Here in this one, they are talking about the back off. I'll just postpone it a little bit. I'll jump again to the differential sticking. So there are many conceptions about differential sticking that you cannot get a warning sign prior to getting the stuck. Like differential sticking only happens with a water-based mud. Fluid loss is the key to avoid differential sticking, and the only way to avoid differential sticking is to operate with minimum overbalance. Differential sticking only comes into play when you are stationary, and that's all not true. It's not like that. Differential sticking is mainly driven by your contact area, your differential pressure, your mud quality, and filter cake. It's thickness and permeability. These are the main drivers for getting a differential sticking scenario. Besides that, we have the contact time, we have the hole diameter, we have the pipe diameter, we have inclination and formation permeability. So this shape will graphically explain to you how we get our pipe differential stuck. So if you are having a differential pressure between your well bore and the formation, and you are having a high surface area, so the pipe will hang to the walls to your walls, and you're inside a stuck pipe scenario. That's why in so many cases we deploy a spiral drill collars in our tool string to minimize the contact area between your drill pipe or between your tool string and between the formation, because driving down the area, driving down the standoff and the length enhance your chances of not getting a differential stuck. Okay, so as mentioned, contact area is one of the primary reasons why we are getting a differential stuck, and it usually happens when you are having flush drill collars. That's why the spiral drill collars are sometimes recommended to be used near the depleted area where we know that we may have a differential stuck scenario, because by this we are reducing the surface area and the contact between our drill pipe and the formation, and we're reducing the chances of having a differential stuck. Okay, so what about overbalance? So there was a study done by Chevron company. It showed that if you're having a differential pressure greater than 2000 psi, you are increasing your chances of getting a differential stuck. And this happens in vertical holes while using water-based mud. And then later on, they enhanced it and they built on this study by saying that you can increase the threshold of this differential sticking if you are having better mud cake quality. So you can go up to 4,500 psi with a water-based mud in deviated wells, as long as you are paying special attention to the mud being used. You are having a better filter cake quality. So that's impermeable, and that's separating you from the well bore. Okay. So what is the favorable or what is the desirable properties of mud that we need to have to ensure or to minimize the chances of having a differential stuck? The thin, tough, compressible, low perm cake is very essential. That's why the mud engineer should frequently conduct this filtered test on the mud to make sure that it's desirable. It's having proper properties to avoid you from getting a differential stuck scenario. Okay, so this is the shape of how the mud cake should look like in a filtered test. This is a desirable one. It's with low permeability to help you not getting into this differential stacking scenario. Okay, so how can we detect a differential? So the first thing is that you need to track the static friction in the well. So by this is the best indicator for you to determine if you're getting into a differential stuck scenario or not. And while drilling, while connecting, while tripping out, also you need to record all your data, right? You need to rotate first after a connection. Okay, you need to record your peak torque. You need to compare to the dynamic of bottom torque. Okay, and while running casing, you need to record the minimum slack of weight required to get the pipe moving and compare it to the steady state slack of weight. So those are practices and techniques that you can use to detect differential sticking and moreover prevent it from occurring in the first place. Okay, from the equipment standpoint, we should use minimum lengths of PHA. Okay, the PHA should be optimized for jarring impact and impulse increase the likelihood of differential sticking, and also spiral drill collars, as explained earlier, or spiral heavy wheel drill pipe is favorable in case you have a history of stuck pipe in this like in this type of formation, because that will minimize the area between the tool string and the hole, and by this you'll lessen your chance of your pipe stuck. And also you need to design to avoid flush or semi-flush connections. Alternatively, you have to use centralizers and subs or model centralizer PHA, and you need to upgrade the rig to high strength rotary table. Independent traction motor and remote flush mount slips are preferable. Okay, so if I've monitored all those parameters, but still I got into a stuck pipe scenario. What actions should be taken? The first one, you need to apply torque. Okay, and you prepare and pump a spotting fluid. In some cases, it's diesel. Some other companies, they have their black magic or cake breakers. And once you pump this, in extreme cases, it may be necessary to underbalance the well via base oil or water. So you pump a very light pill of base oil or of water to reduce the hydrostatic pressure of the mud. Thus, you will reduce your differential pressure and you will be able to free the pipe. But as mentioned earlier, this thing cannot be decided by one party at the well site. It's a team decision. You need to discuss it with the mud engineer, with the mud logger, with the company man, have a plan, have a hazard analysis and risk control, and then you proceed with the solution. Okay. So this one will put in steps what are the steps we should take to free a differential stuck pipe. So the first step is that we stop the circulation. So by this we are minimizing, or we are putting to zero our annular friction losses, and thus we are removing the equivalence density effect. And then you start slacking off weight in your tool string, you activate your bumpers, right? Then you pick up just above the up weight and perform the step 3 again. You start repeating it. If the string does not move freely using those classical steps, you proceed with pumping the light pill, the diesel pill, and you try again. Okay. The second reaction, if the string does not come free after 5 to 10 jars, you need to pump and soak the releasing pill as per the mud company recommendations. So heavier or lighter pill across the stuck zone. So consider reducing the mud weight to a safe limit, because at all times we have to put in our minds the well control and the hole stability. And once the string is free, we rotate and work the string. We circulate at the maximum rate to clean the hole. We check the mud properties, and we minimize the time for connections and surface and time needed to have the pipe stationary. Okay. Now we are moving to the second type of getting our pipe stuck, which is the mechanical sticking. So with the mechanical sticking, we are having packing off. We are having cuttings accumulated around our tool string. So in such a case, if moving up, you have to start moving up. You apply torque and you start jarring down with minimum force. If you're using a hydraulic jar, increase the jarring down force gradually as the time is progressing. If moving down, apply torque with caution and start jarring up. So those are the scenarios. If you are capable of moving up, you start applying your torque and you jar down. If you're moving down only, you apply your torque and you start jarring up. And you continue jarring until your pipe comes free. Right? The second reaction, if you know that you are in a limestone or a chalk formation, you can start putting some acid that will help you to dissolve the formation and be able to free your pipe. If you are in a salt section, fresh water can be used to dissolve your salt, and then you will be able to free your pipe. And once your pipe is free from the mechanical stuck scenario, you circulate at the maximum rate, you circulate the whole clean, you ream and back ream the whole section, and you circulate the whole clean. Okay. So here is a summary. And Samar will share with you this presentation after the webinar. So I try to summarize everything in a nice table for you to understand the different mechanisms of a stuck pipe and what should be done to tackle this. Okay. And now this is the last section, and this is the conclusion of the presentation. We will talk about the recommended practices that we should apply during different phases of drilling an oil and gas well. So we have to the sound engineering practices during handovers, during the drilling itself, during circulation, during tripping, during surveys, and during emergency procedures and back reaming. So at each stage, as explained in the beginning of my presentation, a stuck pipe event can occur anytime. That's why we should stay vigilant. We should apply the correct drilling procedures in all stages. So during handover, like in a latest survey done by the American Petroleum Institute, and they found out that most of the stuck pipe events happen like in 2 hours after the shift handover. That's why it's a very important phase of the drilling that we need to discuss with our team. We need to make sure to record exactly what happened during the previous shift. We need to record everything. A proper handover, a written handover should be in place to allow the incoming crew to be aware of what's going on, to be aware of all the problem, and to avoid having a stuck pipe event. The second one is the general steps that should be followed during drilling. We need to maximize the movement of our BHA or drill string when it's in the open hole, right? We need to use optimum pipe rotation. We need to record all the tight spots and to pay extra attention while drilling non-troublesome formation. And that can this data can be driven from offset wells or from the pre-drilling designs and analysis done at the town, right? And also we need to avoid at all costs getting our pipe stationary or without circulation in the open hole. We need to avoid back reaming out of the hole unless it's absolutely necessary. So back reaming could be troublesome if not done properly. We need to monitor our shell shakers, to weigh our cuttings, to record their shapes and all that, because those critical parameters we mentioned in the beginning of the presentation that will make you understand where your drilling is going. Is it going properly? You are having your hole clean or not, and all that. And then you need to use trend analysis for all the parameters. It's not only a one parameter thing. No, you need to have a look at the full picture. And you need to ensure your mud is in a good condition and it's up to its design criteria. And eventually you need to minimize the sliding section actions, right? Okay, so hole cleaning practices. While drilling, you need to monitor the shakers. While drilling, you need to ensure that your ROP is within the designed range, right? So high volume of, if you're having high ROP, you should expect high volume of cuttings. If this is not happening, then stop, because those cuttings are still in your wellbore, right? If cuttings are not coming to surface as corresponding to your ROP, they are accumulating in the well and they are causing you a hole cleaning issue. So that's why you have to keep a close eye on this parameter, and you don't drill faster than you can effectively clean the well. So ROP, sometimes you're happy with the high ROP, but in most scenarios, it's not a good thing. You need to have your ROP proportional to the carrying capacity to have adequate hole cleaning and to avoid the cavings and pack off of those cuttings above your tool string. Okay, so prior to getting your tool string out of the hole for changing your BHA or for changing your bed, you need to circulate the hole and rotate the string until the shakers are clean prior to trimming out. You need to circulate a minimum of 1.5 bottoms up for vertical wells and 2 to 3 times for deviated wells. Because as you know, in deviated wells, we have sand bedding into the horizontal section. So that needs effective cleaning and effective carrying. That's why we're increasing the bottoms up volume. We need to use adequate sweeps. We need to rotate and reciprocate the pipe. And we need also to pick up and slack off and rotate the hook loads should be monitored during drilling before and after circulating the bottoms up compared against the theoretical values. In this table, it will give you an idea about the bottoms up volume that you should be used for different inclinations and different hole sizes. So as you can see in the 17 inch to 12 quarter hole with a greater than 30-degree inclination, you need at least 3 to 4 bottom up circulations at optimum parameters to make sure that all the cuttings are clearly cleared from the wellbore. And with the same logic, you can get to know for different inclinations and different hole sizes what volume of bottoms up that needs to be deployed. So building on what mentioned in regards to the recommended practices, we need to understand our geology pretty well. We need to understand our BHA. We need to design the jar placement properly, because the jar is a very critical tool that's used to free our stuck pipes. If you are having a vertical well, you need to maximize down jarring and to ensure that the jar has the capacity as well. In directional wells, you have to optimize the jar impact for up and down. Okay, drilling fluids as well. You need to maintain the weights as low as possible to overbalance across depleted or risky zones. So building on, also this section will talk about the different type of LCM or loss of circulation we use to treat differential stacking, like calcium carbonate. And this one I'll not talk a lot about it because, as you know, as the industry progresses, the mud engineers come up with new chemicals, but the concept is the one that I need to. A loss of circulation material is used to temporarily plug a thief zone so that you avoid the risk of getting your pipe stuck into this, differentially stuck into this thief zone. Okay. So drilling practices, pre-spot, pre-section, pre-trip meetings, avoid drills to avoid differential stuck. Sometimes you have to make a scenario as if you got differential stuck. What are you gonna do? So this drill is very important to get all the team members on board and aligned on what actions or what contingency plan they should follow to cure a differential stuck event. Pipe movement, it should be kept at all times. You should like minimize the times when your pipe is stationary, and cuttings and caving analysis, as mentioned earlier, it's a very good indicator for what's happening. Are you getting the weight of cutting you should get on this rate of penetration or not? The shape of the cuttings also will give you an idea about the differential pressure. Okay. Moreover, also electric logs are used, like a modular dynamic tool. The pressure while drilling are used also to give you an idea about your drilling operation, to give you an idea about your overbalance condition, to give you a figure of your chip hold down effect. So this is also should be considered in high profile applications. Okay, this is the emergency practices we should take. Like if you have an equipment in your, if let's say the mud pumps down, what should you do? You should maintain the circulation for as long as possible. You avoid the periods of having your pipe stationary. If the circulation is not possible, you have to rotate and reciprocate your pipe like 30 feet. So because while reciprocating, try to minimize rotation. If reciprocation is not possible, pipe cannot be rotated with minimal RPM. Okay, if you cannot rotate or reciprocate, you have to connect a circulation bottle and circulate the hole until the problem is solved, right? Because having, let's say, a mud pump breaking down at surface, it will increase your chances of getting your pipe stuck. That's why you have to start applying this playbook to minimize the chances of getting your pipe stuck. A secondary way is to circulate, should be available, right? And circulate the hole clean prior to resuming operation. So those are practices that we should deploy in case we are having any of our surface equipment breaking down in the middle of our operations. And by this, I came to the end of my presentation. The topic is very dense. I tried to cram it up in just 45 minutes. I hope you got some benefit of it. And it was designed for the listener. It's not designed for advanced drilling engineers. The intention is to give you a basis of understanding for this important topic. And for sure, I'm sure that most of you will have a lot of questions, but due to the time of the presentation, will not be able to take questions, but you are more than welcome to share your questions with us on the email address of the training company, and we'll be more than happy to get back to you. And this is just the beginning. We'll organize more training sessions in the future about equivalently important topics. And at the end, I'd like to give the floor to my colleague Samar to end the presentation and talk about the certification and the evaluation. Thank you so much, guys, for your attendance. I'm really pleased to meet you all virtually. And for sure, it's not going to be the last time we'll meet again in the future. Thank you so much.
Okay, thank you, Mr. Ahmed. Hello, ladies and gentlemen. I hope you're doing fine. Concerning any questions, if you are having any kind of question, just try to email us or send an email or send on the WhatsApp group or our website or our social platforms, which are Facebook, LinkedIn, or Instagram. You can send us and you will have your question answered, inshallah. And concerning the certificate, you will be able to receive your certificate on your email and you in a month from now. So there is no need to send us a message asking about your certificate, because you will receive it in a month from now. And guys, there is an important evaluation form that you have to fill out. I will just send it right now. You have like 3 minutes to fill this form. It's an important form for evaluation. So concerning the PDF or the presentation that Mr. Ahmed Al-Attar just presented, you will be able to take it. We will send it for your emails or by a WhatsApp group. Don't worry about this. Okay, guys, thank you for this attendance. We are hoping you're having a very nice day for today's session. Okay, bye-bye.
Thank you so much, guys. Goodbye.
Thank you and goodbye.
Thank you and goodbye.
شكرا.
Thank you and goodbye.
Thank you and goodbye.
Thank you and goodbye.